Hello, this is Mrs. Boots, and we're going to work the practice problems for our polynomials operations lesson. Remember, there are 3 different things we're doing in this lesson: evaluate, add, and subtract. They're all simple operations and they're all related. So for evaluate, write down the equation as you see it, but put parentheses everywhere there's an x. So in number 1, I would have negative 2 with parentheses cubed minus 3 with parentheses plus 18. Do that for every single evaluation statement. Then we can plug in our numbers. Negative 2 parentheses cubed minus 3 parentheses plus 18. Now let's plug in our values. In the first statement, we're plugging in the 0. That's what's in between the parentheses, so that's what I put in my parentheses. In the second statement, it's a negative 1. So we're evaluating for negative 1. In the third statement, we're evaluating for 6. Now, let's plug these in. Well, the first one you really don't have to plug in. You have 0 minus 0 plus 18. That's 18. Easy enough. The second one might be a little tricky. So go ahead and plug that one in. And we get 23. The third statement, remember, plug it in with the parentheses exactly as you see it on everything. So I'd have the negative 2 parentheses with the 6 parentheses cubed. When we plug it in, we get negative 432. The parentheses matter a whole lot when you're looking at negative numbers. It basically is the indicator for the order of operations. Number 2, write down your equation exactly as you see it with parentheses for the x in order to evaluate. Now plug in the number into the parentheses. For the first evaluation, I'm plugging in 0. The second evaluation, negative 1. The third evaluation, I plug in 6. Now let's compute. 0 plus 3 is 3. Negative a half plus 3 is negative 2.5. And half of 6 is 3. 3 plus 3 is 6. Those would be my answers for each evaluation. Number 3. Let's write down our equation with parentheses for the x's in order to evaluate. 2 is on top, parenthesis, minus 5. On the bottom I have parentheses, plus 1. Now plug in the values. The first evaluation is for 0. Plug in a 0 inside the parentheses. The second one is for a negative 1. The last one is for a 6. Now let's step through this. On top, for the first one, I would have negative 5, and on bottom, I would have 1. So my simplified answer is just negative 5. For the second one, on top, I would have negative 7. On bottom, I would have 0. Can I have 0 in the denominator? No. So this one would be no solution. For the last one, I have 12 minus 5 on top, which is 7, and 6 plus 1 on the bottom, which is 7. 7 over 7 equals 2, 1. So the evaluation would be 1 for the f of 6. Number 4. First step, write your equation down with parentheses in the place of the x. Square root of 3, parentheses, minus 2. Now plug in the value that we are evaluating for. The first one is a 0, the second one is a negative 1, and the third one is a 6. So in the first one, I would have the square root of negative 2. That would be I times the square root of 2. For the second one, I would have the square root of negative 5. That would be I times the square root of 5. For the third one, I have 18 minus 2, which is 16. Square root of 16. The square root of 16 is 4. Remember, if we're looking for graphs, the imaginary answers would not be acceptable. We would have to write no solution. Number 5. First, write your equation with parentheses in place of the x's. So I would have x squared, or parentheses squared, minus 5, parentheses, plus 1. Now, plug in the value we're evaluating. The first one, we plug in a 0. The second one, we're plugging in negative 1. And for the last one, we're plugging in 6. Let's evaluate for 0. 0 minus 0 plus 1 is 1. For the second one, I would have 1 plus 6 plus 1 would be 8. So the f of negative 1 is 8. What about the f of 6? That would be 36 minus 30 plus 1, which is 7. Number 6. Write the equation with parentheses in place of the x's. So I'd have 3 times parenthesis divided by the parentheses minus 2. Then we need to plug in our number that we're evaluating. The first one we're evaluating 0. The second one we're evaluating a negative 1. And the last one we are evaluating 6. So the first one, 3 times 0 is 0. 0 minus 2 is negative 2. Is that a no solution? No, it's just 0. Remember, 0 can be on top, but not in the bottom. The second one, I would have a negative 3 on top and a negative 3 on the bottom. Simplified, that gives me a positive 1. For the third one, I get 18 on top and a 4 on the bottom. Let's reduce the fraction. That would be 9 over 2. If you really want, you can give the decimal value of 4.5. Adding and subtracting. Remember, we can only combine like terms. So, on number 1, I start with the highest exponent. I have an x to the 4th. I don't have any other x to the 4th, so I just write that one down. Notice there's a plus sign in front of the parentheses. So I can distribute that, but nothing changes. Now, let's do the x cubes. I only have one x cubed, so I'm going to write that one down. Negative 3x cubed. Now let's do the x squares. I have a negative 3x squared plus an x squared. That gives me negative 2x squared. Now my plain old x's. I only have one plain old x, so I'm going to write it down. And then last but not least, my constants. I have a negative 1 and a positive 9. That gives me positive 8. All my terms have been combined. That is my solution. Number 2. This one has a negative in the middle. So we're going to have to distribute that negative to every single term in the parentheses after the negative. Let's write down what would happen. My first parentheses stay the same. All the terms, all the signs. No changes there. The second set of parentheses, all the signs are going to switch. So I have negative 7x cubed minus x squared plus 19. Now we can combine our like terms. Start with the x cubes. Negative 3x cubed and negative 7x cubed is negative 10x cubed. Now my x squares. Well, it looks like those are going to cancel. Same. Yep, those cancel. Now my x's. I have negative 10x. Now my constants. Well, I've only got one of those. Plus 19. This would be the simplified polynomial. Number 3. I have a plus sign in between, so we don't have to distribute. We can just go to combining like terms. X to the 4th is my highest exponent, so that's where I'm going to start. I only have one x to the 4th, so I'm going to drop it down. 9x to the 4th. Then I look for x cubed. Negative 3x cubed. Now my x squares. I have two of those, so let's add them together. That would be 5x squared. Then my x's. Minus 10x. And last but not least, the constants. Plus 9. This would be the simplified polynomial. Number 4. I have a negative in between my parentheses. That negative must be distributed to every term in the parentheses following it. The first set of parentheses, everything drops down and stays the same. But for my second set of parentheses, all the signs change. So that would be plus 3x cubed minus 7x squared plus 6x plus 2. Now let's combine like terms. I have a plus x cubed and a plus 3x cubed. That gives me 4x cubed. Now my squares. I only have one, so it drops down. Now my x's. I only have one of those, so it drops down. Last but not least, the constant. 12 plus 2. That would be plus 14. This would be the simplified polynomial. Number 11. Number 5. Wow, I'm getting ahead of myself. We're going to distribute that negative to every term in the parentheses after it. So the first set of parentheses, all the terms stay the same. The only ones that change are in the second set of parentheses. I would have plus x cubed minus 5x squared plus 8x minus 11. Now let's combine our like terms. Start with the highest exponent. I only have one x cubed, so I write it down. Then I go to my x squares. 7 minus 5 is 2. So I have plus 2x squared. Now I go to my x's. Minus 2 plus 8. That gives me plus 6x. Then my constants. 5 and negative 11. That would be minus 11. Number 6. I have a plus sign. I don't have to distribute that, so I can go straight to combining like terms. Start with the highest. I have a negative 8x to the 4th with no other x to the 4th. So I simply drop it down. Now, x cubes. I only have one of those. 2x cubed. Now x squares. 6x squared and 9x squared. That gives me 15x squared. Now x's. Minus 13x. I don't have any constants, so this would be my solution. Number 7. I have a negative in between the parentheses. That must be distributed. Everything in the first set of parentheses is going to stay the same, so I'm just going to write it down. My second set of parentheses, all the signs will change. Plus 3x cubed minus 10x. Now let's combine like terms. X to the 4th, there's only one of. X cubed, there's also only one of. There isn't an x squared, but I notice I have two terms with an x, minus 12x. I only have one constant, so I write it down. This would be my simplified solution. Number 8. I have a plus sign in the middle, so I don't have to distribute. Just start with combining like terms. always start with the highest exponent. 4 minus 3, 7 minus 3 is 4. 4x cubed. Now let's do x squares. Both of them are being added. Plus 2x squared. Now the x term. Minus 10x. And then my constant. Plus 19. This would be the simplified polynomial. Number 9. We have a negative in between the parentheses, so we have to distribute the negative to all the terms in the parentheses after. The terms in the parentheses that are in front of the negative sign don't change. Those will remain the same. The parentheses after the negative sign, those terms, the signs will change. Plus 8x cubed minus 4x squared plus x. Now we're ready to combine like terms. Highest exponent is x cubed. 9 plus 8 is 17. 17x cubed. Now look at the squares. 19 minus 4 is 15. Now my x terms. There's only one, so we write it down. Now my constant, plus 9. This is the simplified polynomial. Last practice problem for this lesson. Start with the highest powers. Well, what about the sign in the middle? It's a plus sign, so we don't need to distribute. Highest power is a 3. So I have 1x cubed minus 3x cubed. That's going to be negative 2x cubed. Now my squares. I don't have any of those. Well, let's look at our x's. 7x and 6x is 13x. Now the constants. 12 plus 2 is 14. This is the simplified polynomial, and this concludes all of the practice for simplifying polynomials.